Okay, hello everyone. As I said during last class, today what we're going to do is do an exercise on, well, we're going to do two exercises actually, but with this first video, we're going to do a video on settling basins or settlers or settling chambers. Okay, so the statement of the exercise is the following. A paper recycling plant generates 8 cubic meters per hour of processed water containing small fibers and ink particles after pulping. Before reuse, the water is treated with dissolved air flotation, followed by a lamellar settler. Okay, so here is the equipment that is used. You are tasked with designing the lamellar settler stage. The design criteria are: the SLR, or the surface loading rate, equals 1.2 cubic meters over square meters hour, and the retention time is 4 hours. So the first question is, what is the minimum settling area required? Okay, so remember that SLR is the same as surface loading rate, and it is defined as the flow rate or the volumetric flow rate over the settling area. So if we put this in formula, this would be Q over A. So we're required to determine the minimum settling area. So the minimum settling area would be A, since SLR equals Q over A is going to equal Q over SLR. And in this case, we are talking about 8 cubic meters per hour. Shoot. Okay. It was, sorry. So the area is Q over SLR. The flow rate is 8 cubic meters per hour. And that is going to be divided by the SLR, which is 1.2. 1.2 cubic meters per square meter hour. So some of these are going to get cancelled out. The cubic meter per hour is going to get cancelled out with the cubic meters per hour. And so in this case, the answer is going to be, and I have it over here somewhere, hidden. The answer is, moving on to the second question. What is the effective volume of the settler? This is determined by the retention time, and the retention time equals the volume of the system of the settler divided by divided by the volumetric flow rate. So in this case, or another more simple expression, V over Q. So the volume is going to be the retention time times the volumetric flow rate, and that would be 4 times 32, and that's going to, 4 times 8, and that's going to be 32 cubic meters. Now, moving on to our last question. Here we have to compare the dimensions of the reflux classifier over the lamellar settler over here. So how we're going to compare this? We are going to compare these by calculating the settling area a certain equipment has over its volume. Okay, so that's how we're going to compare this is going to be the measure to compare the footprint, and by footprint I mean environmental footprint, over of both types of settlers. Okay, so starting off, you're going to start with the reflex classifier, which is the one with the ones established here in the question or stated in the question. And we're going to calculate this, as I didn't say it above, we're going to calculate this as the settling area. Oh, I said it, that it's a settling area over the volume. So for the reflux classifier, this is going to be 10 over 40. So this is going to be 0.25 square meters over cubic meter. And the next one, which would be the lamellar settler. This is going to be, let's look at the numbers, 6.67 over 32, and this equals 0.2 square meters over cubic meter. So now with these two, we have to establish whether which one of these has a larger footprint. Now, by footprint, it's basically we're trying to look for a system that is effective in terms of settling. Okay, so it would be with a good settling area per unit of volume. So in that sense, we are looking, or we should select an equipment with a higher effective settling area per unit of volume. So in that sense, the one with the smaller and this would be the one with the smaller footprint, okay? Because in this sense, we're going to have this equipment in the same unit of volume. It's going to be more effective in terms of settling, okay? So in this sense, the one that has a smaller footprint or a better footprint would be the reflux classifier. Okay? Okay, so that would be all for this exercise over here.